Good morning or good afternoon whenever you're watching this video. So today we're going to take the Pythagorean theorem and we're going to use it in order to classify triangles. Okay? But first off, the first concept is called the triangle inequality theorem. And it basically says to form a triangle, the sum of two sides must be greater than the third side. All right, because what side lengths make up a triangle? It can't just be any side lengths in the world. All right, the triangle inequality theorem says that if I add two of those side lengths together, it better be bigger than the third side in order to make a triangle. All right, and the way we can kind of check this is we do the small side plus the large side. Oops, sorry. Back it up. Small side plus the medium side, and that has to be greater than the large side in order to make three sides and three vertices like you see in triangle ABC. Okay, so go ahead and let's look at example 1. Let's prove whether or not a triangle exists. So can the segments with 8 meters, 3 meters, and 5 meters form a triangle? Well, we've got the small side, the medium side, and the large side here. So we just check. 3 plus 5, is that greater than 8? Small plus medium, is that bigger than the large? So 3 plus 5 is 8. Is 8 greater than 8? No, that's not true. That's false. So no, this is not a triangle. Okay? So what does this look like? Like, what is the triangle inequality theorem? Why doesn't this make a triangle? Well, let's say we had a side length of 8. Okay? That's 8 units long. And then we had another side length of 5 and another side length of 3. Okay? So the large side is 8. This medium side here is 5, and this blue side here is 3. All right, so what you don't see is that, draw this out, they actually connect. This is a collapsed triangle because the sides are on top of the big side. All right, now if I try to raise the yellow side up and keep it to be 5 units long, and if I raise the blue side up and keep it to be 3 units long, there's this gap here where they won't intersect. They only intersect down here on the collapsed triangle. But if I start to raise that, they will no longer be able to connect. Therefore, they won't be able to form a triangle. All right, so that's an example of a collapsed triangle. All right, what about in part B? So we got 1.8 feet, 3.5 feet, and 5.2 feet. All right, so we got small, medium, and large. So we want to check, does the small, 1.8, plus the medium, 3.5, is that greater than 5.2? Well, we got 1.8 plus 3.5, which is 5.3. 5.3 is greater than 5.2, so yes, this does form a triangle. All right, they will be able to have 3 side lengths and 3 vertices to form a triangle. And then last but not least, we've got 6.1, 11.3, and 4.2. So we got the small, the medium, and the large. So 4.2 plus 6.1, is that greater than 11.3? Well, 4.2 plus 6.1 is 10.3. Is 10.3 greater than 11.3? No, that's not true, so this is not a triangle. Okay, so just to kind of visualize why this doesn't make a triangle, we've got this bottom, we got the large side, which is 11.3. We've got the small side, which is 4.2, and the medium side here is 6.1. And the small side is 4.2. So even when it's a collapsed triangle, they never meet. So if I wanted to expand this to try to connect them, they would never meet if I raised those up from the collapsed triangle. There's this huge gap here. So they would never intersect. Therefore, they would never be a triangle because they can't form that third vertice. Okay? So that is the first step in these notes, because as we go on to classify triangles, the first step will always be, is it a triangle? Does it satisfy the triangle inequality theorem? Small side plus medium side greater than large side. That's going to be the first step in these problems that we do. Okay, so make sure you tune into the next video to see how we can apply this and take it a step further.